Now we shall discuss in this particular video about electrolytic cells. These are the cells or device in which the electrical energy is used to carry out reactions which are non-spontaneous and give chemical energy. And the basic process that it's undergoing is called as electrolysis. And in electrolysis, we will explain this with the process. You have two electrodes which are dipped in a same solution, and the solution should be either aqueous or molten. Let this be molten NaCl. And in this you have two metallic rods which are connected to two terminals. This is positive terminal and this is negative terminal. So you have an external source, electrical potential आप दे रहे हो और फिर NaCl का decomposition होगा और वो further product में convert होगा. Now normally NaCl in molten state, it will just break down as Na plus and Cl minus. No further reaction occurs without giving any kind of electrical energy. So here you have in this container, solution तो है, मैं general में लिख देती हूँ. You have few Na plus, Cl minus, Na plus, Cl minus. So what happens is, once you on the current, ions तो बने हुए थे, current apply करोगे तो ions move करेंगे. So the ion starts to move towards the opposite charge electrode. That is, the cation will move towards the negative charge electrode and anion will move towards the positive charge electrode and undergo respective reaction to become neutral. So Na plus is going towards negative electrode and it will gain electron and convert into Na metal. ठीक है, तो Na plus नेगेटिव की तरफ आ रहा है, इलेक्ट्रॉन गेन कर रहा है, यानी कि ये रिडक्शन अंडरगो कर रहा है. और रिडक्शन हमेशा इलेक्ट्रोड जिस पे होता है वो कैथोड होता है, एंड हियर कैथोड इज अ नेगेटिव टर्मिनल. सिमिलरली Cl minus is moving towards anode, that is a positive terminal, and Cl minus will go there, lose electron and form chlorine atom. It undergoes oxidation on anode, which is the positive terminal of the battery. तो जो इलेक्ट्रोड पॉजिटिव टर्मिनल से कनेक्टेड है, एनायन आया, इलेक्ट्रॉन लूज किया, बट Cl के फॉर्म में स्टेबल नहीं है. So two chlorine atom will form a chlorine molecule and chlorine gas is released from anode. So you require two chloride ion, two chlorine atom, two electron. और दो क्लोराइड कब बनेंगे? जब दो मॉलिक्यूल NaCl के होंगे, तो दो Na plus, दो Cl minus. So two Na plus will gain out two electron to form two Na. So the reaction of what happens is overall of the addition of the two. So two molecules of NaCl, when you give electrical energy, that is when you undergo electrolysis, it forms sodium and chlorine gas. Sodium is getting deposited on cathode, which is a negative terminal, and chlorine is released from anode, which is the positive terminal of the battery. So this reaction was not taking place by itself. We need to give electrical energy, and the device which is converting electrical to chemical is electrolytic cell, and the process that it carries out is called as electrolysis. So this is electrolysis. You have a electrolyte in aqueous or molten state. It breaks down into ions. Now these ions, when you give electric current, will move towards opposite charge electrode and undergo respective reaction, either reduction or oxidation, and convert into neutral stable atom. And the number of electron needs to be balanced in both the reduction and oxidation. Here the reduction is taking place again on cathode, but here the cathode is negative terminal of the battery, and oxidation is taking place on anode itself, but that is connected to the positive terminal of the battery. So oxidation always on anode, reduction always on cathode. Electrolytic cell में anode होता है यहाँ पे positive और कैथोड होता है नेगेटिव, बट इलेक्ट्रोकेमिकल यानी कि गैल्वेनिक सेल में रिवर्स होता है साइन. ओनली दैट इज अ डिफरेंस. रिएक्शन अभी भी एनोड पे ऑक्सीडेशन है और कैथोड पे रिडक्शन है. सो दिस इज इलेक्ट्रोलिसिस. नाउ टू अंडरस्टैंड मोर कि कितना सब्सटेंस डिपॉजिट हो रहा है एक इलेक्ट्रोलिटिक सेल में, एनोड पे या कैथोड पे कितना अमाउंट ऑफ सब्सटेंस या गैस रिलीज हो रही है, एक क्वांटिटेटिव रिलेशनशिप वाज स्टडीड by Faraday, and we have a law called as Faraday's law for electrolysis. इलेक्ट्रोलाइसिस होते करते वक्त जो भी अमाउंट सब्सटेंस का डिपॉजिट हो रहा है एक इलेक्ट्रोड पे या गैस रिलीज हो रही है किसी भी रिस्पेक्टिव इलेक्ट्रोड्स पे, कितना क्वांटिटी करंट पास हो और कितने सब्सटेंस डिपॉजिट या रिलीज हो रहे हैं, दैट रिलेशनशिप वाज फर्स्ट गिवन बाय फैराडे कॉल्ड एज फैराडेज लॉ. So Faraday gave the quantitative relationship. It gives the quantitative relationship between the quantity of electric current and the amount of substance deposited and released. And the first law of Faraday states that the amount of substance deposited or liberated from an electrode is directly proportional to the quantity of electricity passed through it. If W is the amount of substance deposited or liberated and Q is the quantity of electricity, then W is proportional to Q, or W is equal to a constant Z into Q, where Q is current into time, where I is the current and T is the time. I करंट है इन एम्पियर एंड टाइम कितनी देर तक वो करंट पास हुआ इन सेकेंड्स, एंड Q इज द क्वांटिटी ऑफ इलेक्ट्रिसिटी दैट इज इन कूलम. Z is the proportionality constant called as electrochemical equivalent, and this Z is equal to the equivalent weight upon Faraday's constant. Equivalent weight upon Faraday's constant. So the amount of substance deposited or liberated is proportional to the quantity of current passing through it, and the quantity of electricity is time into current, and the electrochemical equivalent is equivalent mass upon Faraday's constant. So by using the equation you can get the mass of the substance deposited or liberated. So W is equal to E by F into I into T. डायरेक्ट इक्वेशन में इक्विवेलेंट मास है, अगर एटॉमिक मास पता है या मोलर मास पता है उसको J फैक्टर से अगर आप डिवाइड कर दोगे, सो यू कैन गेट दिस इक्वेशन अगेन. इक्विवेलेंट वेट पता होना चाहिए, वो मोलर मास अपॉन J फैक्टर होता है. नाउ द सेकेंड लॉ व्हिच वाज गिवन बाय फैराडे इज बेसिकली व्हेन यू हैव टू और मोर इलेक्ट्रोलिटिक सेल, दो या दो से ज्यादा इलेक्ट्रोलिटिक सेल होते हैं, दिस इज द सेकेंड लॉ. So when you have two electrolytic cell and the two electrolytic cell are connected in series, okay, and to the external source, so what will happen is the amount of substance deposited is directly proportional to the quantity of electricity, or you can tell it is proportional to the electrochemical weight. W2 would be proportional to E2. So the ratio W1 upon W2 is equal to E1 upon E2. Series में connected होते हैं तो quantity of electricity is same in both the electrolytic cell. So if two electrolytic cell are connected in series और दोनों electrolytic cell में same quantity of electricity pass हो रही है, यानी कि Q same है in both the case. पहले सेल में W is proportional to Q, W1 is proportional to Q, W1 is equal to Z1 into Q, और W1 is equal to IT तो सेम है करंट, Z1 क्या होगा E1 अपॉन F, ठीक है, एंड W2 is proportional to Q, which is W2 is equal to Z2 into Q, और W2 is equal to E2 upon F. So I have equation 1 and 2. When I take 1 and 2, 1 divided by 2, I get W1 by W2 is equal to E1 by E2. So this is a mathematical expression for Faraday's second law, that the amount of substance deposited on both the electrode is directly proportional to the equivalent weight of the chemical deposited on it. So W1 upon W2 is equal to E1 upon E2, and these are used for quantitative relationship कि कितनी quantity of electric current हम pass कर रहे हैं और कितना substance deposit हो रहा है. Accordingly we'll get the answer. And also to understand this Faraday's constant, we know that if you have a metal, say Na plus है, Na plus एक इलेक्ट्रॉन ले रहा है और Na में बदल रहा है, we normally tell that 1 mole Na plus gains 1 mole electron to form 1 mole of Na. ठीक है, तो एक इलेक्ट्रॉन का चार्ज कितना होता है? व्हाट इज द चार्ज ऑफ 1 इलेक्ट्रॉन? 1.6 10 to the power minus 19 coulomb. Therefore, what would be the charge of 1 mole electron? 1 mole electron would have a charge as Avogadro number into 1.6 10 to the power minus 19 coulomb per mole, and the quantity of electricity required by 1 mole electron is 96,500. When you multiply this, you will get 96,500 coulomb, and this is called as Faraday's constant, that is F. तो 1 mole electron का charge है 96,500 coulomb. So I can tell the charge of 1 mole of electron is 96,500 coulomb per mole. This is the charge of 1 mole of electron. Here 1 mole of electron is utilized to form 1 mole of sodium atom. So if you are having a metal ion, say suppose copper ion, gains 2 electrons to form copper. So 1 mole of copper ion needs 2 mole of electron to form 1 mole of copper. तो 1 mole copper deposit कब होगा? 1 mole of copper deposits when 2 mole of electron quantity charge is passed through it. 2 mole of electron flows through it. 2 mole electron का charge कितना होगा? 2 into 96,500 coulomb. That is 2 into Faraday's constant. तो इतनी क्वांटिटी ऑफ इलेक्ट्रिक करंट जब पास होगी, 2 into 96,500 कूलम ऑफ करंट जब पास होगा, क्वांटिटी ऑफ इलेक्ट्रिसिटी, इतना चार्ज जब फ्लो होगा तब 1 मोल कॉपर डिपॉजिट होगा. और 1 मोल कॉपर का मास, उसके एटॉमिक मास जितना होता है, दैट इज 63.5 ग्राम. सो टू डिपॉजिट एनी अमाउंट यू हैव Faraday's constant, and this is the quantitative relationship between the amount of substance deposited or liberated and quantity of charge flowing through it. And this was explained by Faraday, called as Faraday's law.